So this is one of those topics that you may have seen this in Gen Chem 1. You may not have seen this. So the way I'm going to approach this topic is to start completely from scratch, and let's make sure that we're all on the same page. So what we want to do is balance an oxidation-reduction reaction. But the way that we're going to do this is, is to look at this redox reaction if it's in an acidic or in a basic solution. So there's a series of steps that we got to follow when we do an acid-base balancing act in an acidic or basic solution. So I'm going to write out the rules, and then we're going to try to do this once from the acidic side and then once from the basic side, so that way we got this down pat. All right, so let's go through the directions of how to balance a redox reaction. So the first step is write the unbalanced net ionic equation. Okay. After that, step two. Step two, what we want to do is decide which atoms are oxidized and which are reduced. Okay. And then once we do that, we write the two unbalanced half reactions. Okay. Once we do that, after step two, then the next part is that we balance both half reactions except for oxygen and hydrogen. Okay, so now step four, let's worry about the oxygen first. All right, so we balance each half reaction for oxygen by adding water to the side with less oxygen, and balance for hydrogen by adding H plus to the side with less hydrogen. All right. Step 5. Balance each half reaction for charge by adding electrons to the side with greater positive charge. By adding electrons to the side with greater positive charge. Oops. By adding electrons to the side with greater positive charge, and multiply by suitable factors to make the same number in both half reactions. Okay, and then once we do that, add the two half reactions together. Okay, so these are the directions for the acidic solution example. What I'll do is go through the same set of directions when we get to the basic, and I'll talk about the way that we're going to modify that. But this gives you a pretty good indication of how we're going to balance a redox reaction. Let's go through this one more time. All right, so the first step, write the unbalanced net ionic equation. Decide which atoms are oxidized and which ones are reduced, and then write the two unbalanced half reactions. Step 3, balance both half reactions except for oxygen and hydrogen. Step 4, balance each half reaction for oxygen by adding water to the side with less oxygens, and balance for hydrogen by adding H plus to the side with less hydrogen. Step 5, balance each half reaction for charge by adding electrons to the side with greater positive charge and multiply by suitable factors to make the same number of charge in both half reactions. Step 6, add the two half reactions together. All right, so let's try this out. So here's our problem. Here's our equation. This is an acidic solution. You got NO3 minus, which is aqueous, plus copper solid, yields NO plus Cu2 plus. All right, so let's try to figure out what's going on. Copper is a dead giveaway because copper's oxidation state is 0 on the left-hand side and copper 2 plus on the right-hand side. So right off the bat, one half reaction is going to be copper is going to copper 2 plus. Okay. Now, since copper is going from 0 to 2 plus, it's losing electrons. So copper has to be oxidized. Okay. Now, what about the species that's being reduced? So we should take a look at the oxygens first. So you've got oxygen and NO3 minus. So in order for that to happen, NO3 minus, that oxygen should be a -2. So if you've got 3 oxygens, -2 times 3 will give you -6. To get a -1 charge, nitrogen must be a +5. Okay. On the right-hand side, if oxygen here is -2, nitrogen has to be +2. So there you go. So it looks like nitrogen and NO3 is going to become NO on the right-hand side. And so that's the one equation we're going to have to deal with. We're going to have to play around with. All right. So let's do that first. Let's play around with that. So if we've got NO3 minus is yielding to go to NO. All right, so we wrote the half reaction. We need to balance this. So we are missing, if you notice on the left-hand side, we've got 3 oxygens. On the right-hand side, we've got 0. We got 1. So in order to balance this, we need to add 2 waters to the left-hand side. All right. So I'm going to write plus 2H2O. So that way the number of oxygens is now equal. You got 3 on each side. Now that means you've got 4 hydrogens on the left. You've got 4 hydrogens on the right. 2 times 2 gives us 4. So to balance that out, what I need to do is add 4 hydrogens or 4H plus to the left. So I'm going to rewrite this equation now. 4H plus, which is aqueous, plus NO3 minus, which is aqueous, yields NO, which is a gas, plus 2H2O. All right. So we're good. Now the oxygens are balanced. Now the hydrogens are balanced. We're good. Now we need to balance each half reaction for charge. And we're going to have to add electrons to the side with a greater positive charge. So you've got 4 times plus 1, which is plus 4, plus a -1. So on this left-hand side, you've got a plus 3 charge. On the left-hand side, none of this is charged, so 0. So on the left-hand side, you got a plus 3 charge. Okay. So what I'm going to do, in order to get this back to 0, I need to add in 3 electrons to this side as well. So let me do that. So 3 electrons plus 4H plus plus NO3 minus yields NO plus 2H2O. All right, so that half reaction is balanced. So we're good. Now we got to work on the other half reaction. So that was copper is solid and it becomes copper 2 plus. Okay. To balance that out, you know that we have to add 2 electrons to the right hand side. And now that's balanced. All right, now the only thing that we're missing here, I mean, we don't have to worry about oxygens and hydrogens for the second half reaction. The only problem is you've got 3 electrons on one half reaction, 2 electrons on the other. Okay, so what we're going to have to do is multiply by suitable factors so that way we get to 6. So the only way that this can work is if we multiply this half reaction by 3, the copper half reaction by 3, and then we're going to multiply the nitrate half reaction by 2, and so that's going to get us the right amount. So let's do that. What I'm going to do is rewrite the 2 half reactions and then add them up and see what we've got. So 2 times 3 electrons give us 6 electrons, plus 2 times 4, which could give us 8H plus 2 NO3 minus, yields 2 NO gaseous plus 4 H2O liquid. And then let's do the same thing for the copper half reaction. So that would be 3 Cu0, copper at elemental, and then 3 copper 2 plus, aqueous, plus 6 electrons. Okay. Now, one thing I do want to point out, notice on the left-hand side you have 6 electrons, on the right-hand side you have 6 electrons. That's even. So you need the electrons to be on equal on both sides, so that way they cancel out. So that's actually one thing that does cancel out on both sides, the electrons. Okay. So adding up the two equations, you're going to get this. 8H plus 2 NO3 minus plus 3 copper elemental 0 yields 2 NO gaseous plus 2 waters, plus 4 waters plus 3 copper 2 plus. And there's your balanced redox reaction for the acidic solution. So let's take a look at balancing a redox reaction in a basic solution. So this does change a little bit. So let's go back to the directions. So the directions is going to veer off right at this point, at the end of step 4. So what I'm going to do is let's make a note here. Okay. So here, what I'm going to do is write 4A. So this is going to be where we modify. So step 4A here, what we're going to do is once you figure out the hydrogens, okay, you're going to neutralize the H plus that you add by adding the same number of OH minus to each side of the equation. Okay, once you do that, your next step is to combine H plus and OH minus on the same side to form water. And once you do that, remove any water molecules appearing on both sides of the equation. Okay, and then after that you'll balance each half reaction for charge, and then you should be good to go. So yeah, that's the only difference between an acidic and a basic solution. Once you add the H pluses, then we got to add, for every H plus you got to add an OH minus. And then you make sure the OH minus is added to both sides. All right, so let's try this out. So here's our problem. You got FeOH2 is a solid plus O2 gas yields FeOH3. All right, so what we want to know, what are the charges of our species? What's being oxidized? What's being reduced? Okay, so oxygen. So hydroxide ion is always going to be -1. Okay, so -1 times 2 on the left-hand side should give you a plus. Will give you -2. That means iron has to be 2 plus in order to balance out the 2 hydroxides. Okay, all right. So OH minus is going to be -1. Oxygen O2 by itself is 0, and then FeOH3, OH is still going to be -1. -1 times 3 is -3, so that means iron has to be +3. All right, so one compound is going to be this, or one half reaction is going to be this. You know, you got iron that's going from 2 plus, and it's becoming 3 plus, Fe3 plus. So that's one half reaction. The other half reaction is you got oxygen gas, being incorporated into this FeOH3 thing. Okay. And so that's going to be a little bit tricky. All right, so look, we've got one half reaction. Let's deal with that. Fe2 plus. We know that's solid. And it's becoming Fe3 plus. In order for that to happen, it's got to release 1 electron. Okay. All right, let's worry about the other half reaction. You've got O2, and it's forming something on the right-hand side. So to balance that out, okay, to balance out the right-hand side, we have to add oxygen. We have to add water. Okay. Now, we have to add 2 waters to balance out the oxygen, the O2. All right. So we're good. We're doing okay so far. Now, we added 2 waters, so we got the oxygens right, but the number of hydrogens is not right. So we've added 4 hydrogens to the right. We're going to have to add 4 H plus to the left. Okay. So 4 H plus O2 yields 2 H2O. All right, now, since it's basic, for every H plus we add, we've got to add OH minus. So let's do that. So 4 OH on both sides. Okay. All right, so then for every H and OH that we have on the left-hand side, that's going to combine to form water. So we've got 4 H2O, 4 water molecules formed from the 4 OH and the 4 H plus, and that becomes liquid, not aqueous. Let me rewrite that. Okay, plus O2 yields 2 H2O plus 4 OH minus. All right. Now, the last thing we got to do is we've got to, whatever waters that we've got on the left and the right, we got to cancel out. So we've got 2 on the right. We've got 4 on the left. So those cancel out on the left, and that becomes a 2. All right. Now, here's where it gets interesting. All right. So if we check our charges, on the left-hand side, we've got 0. On the right-hand side, we've got -4. So what we're going to have to do is add 4 electrons on the left-hand side to balance out the right-hand side. So let's rewrite the left-hand side. 4E minus plus 2 moles of water plus O2 yields 4 OH minus. All right. Okay, so we're good. Now, that side, that half reaction is completely balanced. Over here with the other half reaction, since we've got one electron here, we need to multiply this whole half reaction by 4. So that way, we've got the same number of electrons. So let's bring that equation down here. So 4 Fe2 plus solid becomes 4 moles of Fe3 plus aqueous plus 4 E minus. All right, so adding up our two half reactions, the electrons cancel out, and here's what we got. 4 moles of Fe2 plus 2 moles of water plus O2 gas yields 4 moles of Fe3 plus plus 4 moles of hydroxide ion. And there it is. There's your balanced chemical reaction. All right. Now, just to summarize, for electrochemical reactions, we have to specify many factors, including the reaction species, the product species, the phases, and the concentrations. So all of this. So it's vitally important for electrochemical reactions that we specify everything for that type of reaction.